फ्रेंड, मैं आज आपके साथ डिस्कस करने जा रहा हूँ द रिप्रेजेंटेशन ऑफ ग्राफ डेटा स्ट्रक्चर इन द कंप्यूटर मेमोरी। कंप्यूटर मेमोरी में आप इस डायग्राम को तो रिप्रेजेंट कर नहीं सकते हैं। वी नीड सम डेटा टू रिप्रेजेंट दिस डायग्राम इनटू द कंप्यूटर मेमोरी। सो देयर आर बेसिकली टू रिप्रेजेंटेशन. Number one is adjacency matrix and other one is adjacency list. Adjacency matrix basically a two-dimensional एरे, और जब हम ग्राफ को रिप्रेजेंट करते हैं विद द हेल्प ऑफ एडजेसेंसी लिस्ट, तो बेसिकली वी आर यूजिंग ए डेटा स्ट्रक्चर लिंक्ड लिस्ट. एडजेसेंसी मैट्रिक्स में हम टू डायमेंशनल एरे का यूज करने जा रहे हैं. एडजेसेंसी लिस्ट के थ्रू जब हम डेटा स्ट्रक्चर ग्राफ को रिप्रेजेंट करेंगे तो वी विल यूज लिंक लिस्ट डेटा स्ट्रक्चर. यहाँ पर हमारे पास दो ग्राफ दिए हुए हैं, एक डायरेक्टेड ग्राफ है, दूसरा अनडायरेक्टेड ग्राफ है. उसको हम कैसे एक 2D एरे में रिप्रेजेंट करेंगे, तो फर्स्ट हम देखने जा रहे हैं एडजेसेंसी मैट्रिक्स. टू डायमेंशनल एरे है, दो सब स्क्रिप्ट होंगी. वन सब स्क्रिप्ट विल रिप्रेजेंट row, other one column. If there are n node in the graph, then this, for example, then there are n rows, n column. और अगर हमारे एरे का नाम है ADJ, then n rows, n column. In our example, there are 4 rows and 4 columns because total number of nodes are 4. Each row denotes a single node. For example, row 1 denote node A, row 2 denote node B, row 3 denote node C, same as row 4 denote node A. इस तरीके से फर्स्ट कॉलम डिनोट करेगा नोड A को, सेकंड कॉलम नोड B को, थर्ड कॉलम नोड C को, फोर्थ कॉलम नोड D को. जितने नोड उतनी रो, जितने नोड उतने कॉलम. यहाँ 4 नोड है हमारे पास, तो 4 रो और 4 columns. How the entries of this adjacency matrix or adjacency array, two-dimensional array, will be made with this rule. Any entry of array ith row jth entry will be done. The entry will be 1 if there is an edge between node I to node J. अगर नोड I और नोड J के बीच में कोई एज है तो एंट्री होगी 1, अदरवाइज एंट्री इज 0. Let us fill the adjacency matrix related to this graph, directed graph. There is no edge from A to A, क्योंकि कोई लूप नहीं है, hence the value is 0. There is a single edge from A to B, there is an edge, entry is 1. From A to C, there is no edge, entry is 0. From A to D, there is an edge, entry is 1. इसी तरीके से यहाँ पर from node B to A, yes, there is an edge, entry is 1. From B to B, no loop is there, hence entry is 0. From B to C, there is an edge, entry is 1. From B to D, yes, there is an edge, entry is 1. Again here, from C to node A, there is no edge, entry is 0. From node C to node B, no edge, entry is 0. From C to C, no loop is there, entry is 0. From C to D, there is an edge, yes, the entry is 1. From node D to node A, yes, there is an edge, entry is 1. From node D to B, there is no edge, entry is 0. From node D to node C, there is an edge, entry is 1. From node D to D, there is no loop, hence entry is 0. So this is adjacency matrix 4 cross 4. Now this graph can be represented in computer memory with this two-dimensional array. What about if there is an undirected graph? Let us construct the adjacency matrix. 4 nodes are there, 4 rows, 4 columns. A, B, C, D. Column 1 represents one node, column 2 represents another. Same here for row. Let's see. If there is an edge, entry will be 1. If there is no edge, entry will be 0. A to B, there is an edge, entry is 1. No loop. A to A, there is no loop, no edge, entry is 0. A to C, there is an edge. A to D, there is an edge. B to A, there is an edge. B to B, no loop, hence entry is 0. B to C, there is an edge. B to D, there is an edge. C to A, there is an edge. C to B, there is an edge. C to C, there is no loop, no edge, entry is 0. C to D, there is an edge, entry is 1. D to A, there is an edge, yes. D to B, there is an edge. D to C, there is an edge, and D to D. So this is the adjacency matrix, or you can say the representation of this graph in the computer memory with the help of a two-dimensional array. What about weighted graph? Assign few weights in this example. 2, 3, 7, 4, 6, 5, 8, 9. We assign. Now this is a weighted graph. What will be the adjacency matrix? Here, any entry, ith row, jth column will be given as, if there is an edge, then the entry will be the weight of edge w. Otherwise, entry will be 0. If there is an edge from node I to node j, then the entry at ith row, jth column will be weight. Otherwise, if there is no edge from node I to node j, entry will be 0. Let us complete the adjacency matrix of this weighted graph here. How to store this weighted graph into the computer memory? Total number of nodes are 4. So 4 rows, 4 columns. First row denote one node, second row, second node, third row, third node, fourth row, fourth node. Same here for column. First column, second column, third column, fourth column, first node, second node, third node, fourth node. Just see, from A to A, there is no edge, entry is 0. From A to B, there is an edge and weight is 2. From A to C, there is no edge, entry is 0. From A to D, there is an edge, yes, entry will be the weight of edge AD, 8. From B to A, yes, there is an edge. So entry will be the weight of edge BA, that is 3. B to B, there is no loop, entry is 0. B to C, there is an edge of weight 4, entry will be 4. From B to D, yes, there is an edge of weight 7, entry will be 7. If there is an edge, entry will be weight. From C to A, there is no edge, entry will be 0. From C to B, there is no edge, entry will be 0. From C to C, there is no edge, entry will be 0. From C to D, there is an edge, entry will be the weight of that edge, that is 5. From D to A, yes, there is an edge, entry will be weight, that is 9. D to B, there is no edge, entry will be 0. From D to C, there is an edge, entry will be its weight, that is 6. From D to D, no loop, entry is 0. तो इस तरीके से हम देख सकते हैं कि एक डायरेक्टेड ग्राफ को भी हम एक 2 डायमेंशनल एरे से कंप्यूटर की मेमोरी में रिप्रेजेंट कर सकते हैं। एक अनडायरेक्टेड ग्राफ को भी हम 2 डायमेंशनल एरे, जिसको कि कह रहे हैं एडजेसेंसी मैट्रिक्स, की सहायता से इस ग्राफ को हम अपनी कंप्यूटर मेमोरी रैम में रिप्रेजेंट कर सकते हैं। और सेम एक वेटेड ग्राफ को भी हम विद द हेल्प ऑफ एडजेसेंसी मैट्रिक्स कंप्यूटर की मेन मेमोरी में रिप्रेजेंट कर सकते हैं।